Hello, everyone. We are from Group 4, and today we are going to present our experiment 7 about estimation of heat capacity and entropy generation. So, our team is consists of four people, which is me, Ryan, Arunan, Alif, and Batrisha. So, for introduction for this experiment, the experiment proposed is to estimate the heat capacity and heat generation of a metal. This experiment objective is to experimentally calculate and observe the heat capacity and entropy of metal proposed when the metal are heated and placed into beaker with vinegar. Yes, we're going to use vinegar as the medium. After the heat capacity of proposed metal are calculated, the result will be compared with theoretical values that we get from Google's and books reference. The definition of heat capacity is the amount of energy needed the to raise the object's temperature by 1 degree Celsius. Entropy is the state of disorder, randomness, uncertainty, and commonly called the amount of energy that is unavailable to do work. Entropy is also explained using the second law of thermodynamics, which states that the total entropy of a system always increase or remain constant and never decrease. The objective of this experiment is aimed to estimate the heat capacity of a different metals provided and to estimate the entropy generated with these metals are dropped when these metals are dropped into the container containing vinegar. So the scope that we're going to stick with for this experiment is metal used are only aluminum, iron, and copper. The metal will be placed in a beaker containing vinegar. The amount of vinegar we use in the experiment is 70 milliliter. The temperature of the vinegar used is ranging from room temperature to 80 degrees Celsius, and data is recorded every 10 seconds until equilibrium between the temperature of vinegar and metal is achieved. All right, this is the theory and working principle. Uh, I did write a lot of words at the left, but let me explain to you the drawing so it's easier to understand. All right. So basically, we got the formula to calculate the heat gain by the vinegar and heat loss by the metals. At equilibrium, the temperature of metals and vinegar should be same. The Cp for vinegar is 2.18 kilojoule per kg K. And as you can see in the words, uh, I also include the Cp of aluminum, iron, and copper. And the heat gain by the body with lower temperature should be same with the heat loss of the body with higher temperature. This thing is valid as long as there are no heat lost to the surrounding. That is for specific heat capacity. And now for entropy, entropy of the vinegar of metal could be negative, but the S generation cannot be negative, meaning it must be positive. A process must proceed in the direction that complies with the increase of entropy principle. S gen is more than zero. And you can see we got some formulas over there and that we're going to use. And I did include what I did say there and some illustration over there. Thank you.
So for experimental setup, we've got electronic weighing balance, metal string, smartphone, which we use as stopwatch, electronic thermometer, aluminium metal, the grayish one, the iron metal, the black colored, aluminium foil, 100 millimeter beaker, thermoplate, copper metal, which is the brownish one.
Alright, next we proceed with the procedure. So first, iron metal weighed and recorded by using an electronic balance. Next, 70 milliliter of vinegar is poured into the first beaker and heated by using the thermoplate. The third step is the weighed iron metal is fully submerged into the 70 milliliter vinegar using a metal string. So in this experiment, we estimate the heated temperature of the metal we use is the same with the vinegar water bath. Moving next is the second beaker is filled with the vinegar and the initial temperature of the vinegar is recorded. Once the temperature of vinegar in the first beaker reaches 80 degrees Celsius, the iron metal is immediately transferred into the second beaker. The second beaker is then covered with an aluminium foil cap to avoid heat loss. Next, the temperature of vinegar in the second beaker is measured and recorded at every 10-second intervals until the equilibrium temperature is reached. The last procedure is the procedures are repeated by replacing iron metal with copper metal and aluminium metal.
So for the results, we've got our table which shows the time from 0 to 120 seconds, which is 2 minutes, and the metals used for this experiment, which is copper, iron, and aluminium. So the initial temperature for all copper, iron, and aluminium is 80 degrees, and the initial temperature of vinegar that will be sunken is 27.4 degrees. So as you can see, all three metals achieve a different equilibrium temperature, which is for copper is 32.7 degrees, for iron is 34.2 degrees, and for aluminium is 34.4 degrees. So their corresponding mass has been shown, and the of vinegar, the CP of copper, the CP of iron, and the CP of aluminium have already been stated. The entropy change of metals, which is as metal, has also been calculated. The entropy change of vinegar has also been calculated, and the total entropy generated, which is the entropy change of metals added with the entropy change of vinegar. So the data that we have shown is positive, meaning which is way more than zero, which shows that this process is an irreversible process. So for our result, to find the entropy change of metals, entropy change of vinegar, I've just shown some simple calculations where how to find the entropy change. So entropy change, or as in delta S, can be obtained by multiplying mass of the substance multiplied with the specific heat capacity of the substance and multiplied with natural log, which is uh, ln for T2, which is the final temperature, and divided by T1, which is the initial temperature. So for an example, if you want to calculate the entropy change of copper, so you should multiply the mass of copper with the specific heat capacity of copper, and with natural log, the final temperature of copper divided by the initial temperature of copper. So our S generation, or as we call it as S total, is the total entropy of S for metal added with the total entropy of vinegar. So we should be calculating all three S total for different metals, because since we have three metals, so we will get total entropy generated for three types of metals added with our total entropy change for vinegar. And finally, this is just a bar chart which shows the differences between the specific heat capacity for each metal, the entropy change for each metal, and the entropy change of vinegar affected by these three metals.
Hi and Assalamualaikum. My name is Nur Batrisha binti Abdurrahim and I will be explain about safety procedures for this experiment. First thing first, hand gloves should be worn to avoid burns while holding a hot beaker. Next, do not handle heated glassware or materials directly to avoid burns. And lastly, check all electrical equipment for worn cords or loose plugs before using. Thank you.
Finally, as for references, we got three references which you could mainly refer online. The first of all is Wikipedia, and the second of all is our main textbook, and the third is also a textbook, specific heat of common fluids and solids. All of this could be obtained online. Thank you.